Algebra 2 students, in this video today we will be studying something called nth roots and also another topic called rational exponents. And really another word for rational exponents would be fractional exponents. We'll talk more about that later, okay? Your heading for today is, please write this down, nth roots and rational exponents. Lesson 7.3, and be sure and include today's date. Alright, please copy all this down. Nth roots and rational exponents. Lesson 7.3, and be sure and include today's date. You should have really organized notes, guys, with headings and lesson numbers, dates, and all kinds of stuff, okay? Alright, moving on. Let's start off by looking at some nth roots and exactly what nth roots means, okay? So here we go. Now, first of all, just kind of take some notes. I'm going to ramble here and just kind of take some notes and listen at the same time, okay? We all know that this means the square root of 16. We know that, okay? Why don't you write that down, okay? Square root, okay? So we know this is a square root. We're used to that. But even though you can't see it, there's an imaginary 2 here, not a 1, a 2. And that's why we call it a square root. Now, when we say nth roots, that means we're going to be dealing with any root at all. Any root. You see, not only do we have square roots, we have cubed roots, we have fourth roots, we have fifth roots, we have sixth roots, and etc. Okay? So, we have an infinite amount of roots that we can take. Okay? So what we're going to be looking at today are roots that are not only square roots, but also cubed roots, fourth roots, fifth roots, sixth roots, etc. Okay? That's the first thing I want to show you, so understand what we mean when we say nth roots. That's just saying we're going to be looking at a bunch of roots. Now, it's very important, especially when we get to the rational exponents, it's very important that you remember that when there's no number here, it's a square root, but it's understood to be a what? A 2. That's really important, okay? Now, something else I want to show you that's really, really important, okay? Please write this down. The number inside the radical, we need to know the name of this, okay? Because from now on, I want to say to you students, look at the radicand, and you know what I'm talking about. The number under the radical is called the radicand. This actual box here is called your radical. That's why I just said the number under the radical is the radicand. This number right here, the second root or third root or fourth, whatever this number right here is, that's called your index. Okay? It's very important you know these three terms. I could very well quiz you on this, on a quiz, like put arrows and put blanks right here and have you fill in the blanks. This number under the radical is called the radicand. This box right here is called the radical. This number right here is called the index. Please don't forget that. So do you understand what an nth root is? It's any root, square root, cube root, whatever that we're looking at, okay? Alright, moving on. Now, let's talk about multiple answers for roots and which roots can have a negative radicand. You need to know this, okay? First of all, if I said find the square root of 16, you guys do understand being very specific or technical, being very technical. There's really 2 answers, remember? Negative 4 and positive 4, right? Because negative 4 times negative 4 equals what? 16. And positive 4 times positive 4 equals 16. Do you see that? Okay, you should know that. Same thing with the fourth root. If I said find the fourth root of 16, well, the fourth root of 16 is 2. And negative 2. Oh, Mr. Arrowhead, how'd you know that? Well, because fourth root, right? That means negative 2 times negative 2 times negative 2 times negative 2. In other words, when I ask you to find the fourth root of 16, I'm looking for 4 numbers that are being multiplied together that are the exact same number that equal your radicand. So negative times negative times negative times negative is positive. Also, 2 times 2 times 2 times 2 equals 16. So are you ready for this? Are you listening to me, students? Whenever you're index is even, you might want to write this sentence down. Whenever your index is even, technically, I'm just going to put technically you have a positive and a negative answer. You need to know that. That would make a great test question. Whenever your index is even 2, 4, 6, 8, 10th root, whatever, you technically have two answers that could work. Understand that. Now, if your index is odd, I would write this down if I were you. If your index is odd, you will have one answer. One answer. Okay? One answer. For example, let me show you what I mean. I hope you guys are taking great notes on this. Pause the video all you need to. If I have the cube root of 9, not 9, 8, the only answer is going to be 2, not negative 2. Here's why. 2 times 2 times 2 equals 8, but negative 2 times negative 2 times negative 2 equals negative 8. Think about it. Negative times a negative is positive times a negative is negative. So whenever your index is odd, you do not have a positive and a negative answer. You only have one answer. Do you understand? Index is even. You'll have a plus and a minus answer. I mean, technically speaking, you don't always have to write that, but you understand it's a possibility. When your index is odd, you have one answer. Now, here's something else I want you to write down, okay? When the index is even, the radicand cannot be negative. Cannot be done. You cannot have the square root of negative 8, or the 4th root of negative 8, or the 6th root of negative 8, or the 8th root of negative 8. If your index is even, the radicand cannot be negative. Now, we know what to do with this one. Did we learn this already? If it's a square root, not a 4th root, not a 6th root, not an 8th root. But if it's a square root, we know to make this positive, right? And put what right here? Remember we learned this earlier in the year. Remember? But still, that's not really an answer. That's an imaginary number. So technically speaking, you cannot have a negative radicand if your index is even. However, if your index is odd, your radicand, if I'm going too fast, just pause the video, your radicand can be negative or positive for that matter. It can be either one. If your index is odd, your radicand can be negative. Write that down, know it. This will make two great quiz or test questions. Let me show you what I mean. If I ask you to find the cube root of negative 8, the answer is negative 2. You want me to prove that to you? Alright, I'll prove it to you. The cube root of negative 8 is negative 2. Let's check and see. Negative 2 times negative 2 times negative 2. What do we get? Negative 8. 2 times 2 times 2 is 8. Negative times a negative is positive. Times a negative is negative. So you can have a negative radicand if your index is odd. You cannot have a negative radicand if the index is even. Guys, I hope you're getting this. Go back and watch it again if I'm going too fast, okay? Everything I just said there is very, very important, and it's your responsibility to know that. Let's solve some roots now, okay? Let's jump right into this. Here we go. Alright, take some good notes, please. Let's start with this one right here. The cube root of 64. Now, you can use a calculator, I guess, if you wanted to, but we can do this in our head. I mean, think about it. 2 times 2 times 2. It's a cubed root. So I want how many numbers being multiplied together? 3, but they have to be the same number. 2 times 2 times 2, does that give you 64? No. How about 3? 3 times 3 times 3. No, that gives you 27. How about 4? What's 4 times 4 times 4? That's it. What do you get? 64. 4 times 4 is 16. 16 times 4 is 64. So the cube root of 64 is 4. Is that easy, guys? Just kind of like trial and error. I'm not going to give you one like this. The 4th root of 292,561, okay? We're not going to do that unless we're using a calculator. Then I could, okay? And we're going to learn that later at the very end of this video. Now, let's find the 4th root of 81. So now I want 4 numbers that are the same being multiplied together. How about 2? 2 times times 2 times 2 times 2. It's 16. How about 3? 3 times 3 is 9. Times 3 is 27. Hey, times 3 is 81. That's it. Check it and see, okay? That's it. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. So the fourth root of 81 is 3. There we go. Moving right along. These aren't difficult, are they? They're pretty simple. Okay, now this one here, we're looking for 5 numbers because my index is 5. We're looking for 5 numbers. We call this the fourth root of 81. We call this the third root, or the cubed root of 64. We call this the fifth root of negative 32. We're looking for 5 numbers that are the same. Well, I know it's going to be a negative number because I have a negative 32. Now, if this index was a 6, and you have a negative 32, you would stop and put what for your answer? You would put no solution, okay? You would put that because you have an even index and a negative radicand, okay? Remember what I just taught you. You cannot have a negative number when the index is positive, when the index is even, okay? All right, moving on. Here we go. So we have the fifth root of negative 32. I have an odd index, so I can have a negative radicand. My answer is going to be negative. Let's try 2 real quick here. Let's see. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's it, 32. So my answer is going to be negative 2. If I multiply negative 2 together 5 times, you'll get negative 32. Negative times negative is positive, times negative is negative, times negative is positive, times negative is negative. 2 times 2 is 4, times 2 is 8, times 2 is 16, 16 times 2 is 32. So the fifth root of negative 32 is negative 2. Negative 2. Alright, there it is, guys. Again, one thing about video class, go back and watch this again if you need to, but I really think these are pretty simple. Alright, so that's what we're talking about when we say nth roots. There are square roots, third roots, fourth roots, fifth roots, whatever, and that's how you solve them. Now, these are real nice and pretty. They worked out pretty easy. Later on at the end of the video, I'll show you how to use your calculator to solve ones that are a little more difficult, okay? Alright, now, here's where things get a little interesting, okay? But very important. In lesson 7.1, we looked at negative exponents, and I hope that you will always remember what we learned about negative exponents. That kind of math will be used in all of your future math that you will have. Trust me, okay? Well, now, we're going to look at another type of exponent. So lesson 7.1, we looked at negative exponents. Now we're going to look at rational exponents, okay? Relax. This is just a fancy way of saying fractional exponents. So in reality, do you know what we're doing? We're now going to look at exponents that are what? Fractions. So we looked at exponents that are negative. Now we're looking at exponents that are fractions. Okay, here we go. I want to start off by showing you a pattern or formula, whatever you want to call it, that we are going to use to help us understand and simplify rational exponential expressions, okay? Here it is. Please copy this in your notes. Let's use, we'll use A and B. So we'll say the 8th root of B, and we'll use a C right here, put a power of C, okay? This equals B to the C over A power. Look it over, guys. So I'm telling you right now, if you had the third root of 6 to the second power, that would be the same thing as putting your 6 right here and taking these two numbers here and making them a fraction like this. The exponent goes on top of the fraction. The index goes on the bottom. See this model? The big number here goes right here. And these two numbers here make up your fractional exponent, okay? The exponent here of the radicand goes on top of the fraction. Your index goes on the bottom of the fraction. So now you're seeing, hopefully, what a fractional exponent is. Are you listening to me? A fractional exponent is basically another way to rewrite a what? A root. Or you could turn that around. You could say that another way to rewrite a fractional exponent is to write it like it's a root, or another way to rewrite a root is to write it like it's a fractional exponent. Any way you want to look at it. I could give you this, and you could rewrite it like this. I could give you this, and you could rewrite it like this over here. Okay? So understand this. Now, a lot of students will say, what do you do if there's no exponent, for example? What if we have the fourth root of 6? Well, there's no number here, but there's really a 1 there. So the fourth root of 6 to the 1 would be 6 to the 1/4 power. Or you could say 6 to the 1/4 power is the same thing as the fourth root of 6 to the 1 power. Okay? Are you seeing this okay? Now, what if there was no index here? What if you had the square root of 6? In fact, what if there was no 1 here either? What if you simply had the square root of 6? And I asked you to write that as a fractional exponent. Well, first of all, way back here I told you then that a square root as an unseen 2 right here. So you put a 2 there. And the exponent, even though you can't see it, is a 1. So the square root of 6 would be 6 to the 1/2 power. Okay? Now I'm going to move on. I know it's going to be a little tough, but we're going to apply it to some problems now, so hopefully that'll make it a little easier, okay? So here we go. I want us to simplify all of these, okay? Let's take them one at a time. Okay, I want you to simplify now without using a calculator, okay? No calculator right now, okay? So let's simplify this by writing it as a radical. Here we go. Remember your big number here, the base always goes here, okay? The bottom of your fractional, by the way, this is not 4 3/2. This is 4 to the 3/2 power. This is an exponent right here. This is an exponent. This is an exponent. And this is an exponent. They're not mixed numbers. They're not fractions, okay? It's not 4 3/2. It's 4 to the 3/2 power, okay? Okay, now, the bottom of your fraction always goes here. And the top of your fraction always goes here. Now, are you listening? You can work this 2 ways, and it will always work. You can first take the square root if you want to. So what's the square root of 4? 2, and then bring down the power. And then take 2 times 2 times 2, and you get what? 8. So if you want to, you can take the root first, and the power second. If you don't like that, you can do the power first. So what's 4 times 4 times 4? 64. So now I have the square root of 64, right? 4 times 4 times 4 is 64. And now what's the square root of 64? 8. 8 times 8 is 64. So after I rewrote this as a radical, you can first take the root, which I like to do personally because it makes the number smaller before I raise it to a certain power. But that's up to you, okay? You take the root first. What's the square? Just forget this 3. Pretend that 3 is not there. What's the square root of 4? 2. And then bring down this power. And then 2 times 2 times 2 is 8. Or take the power first, and you get this. And the square root of 64 is 8. Alright, let's try another one. If I'm going too fast, back it up and watch it again, okay? Alright, another example. Now we're mixing in a negative exponent, so right away you're like, okay, great, what do I do? Now hold it. Hold it. We learned this yesterday. Remember how to get rid of a negative exponent? We just learned this yesterday, guys. Put this over what? 1. We just learned this in lesson 7.1. You have 9 to the negative 1/2. You want this negative 1/2 here to be positive. So remember, you take the exponent and its base, and you move the whole thing down to the bottom, and that makes the 1/2. It changes the sign of your exponent. It does not change the sign of your base, okay? So, I already have a 1 in the bottom, times, now bring your 9 down, 9 to the positive 1/2. What's left up top? Nothing. So what do you put? 1. Everybody good with that? All I did was make the exponent become what? Positive. And we learned how to do that in lesson 7.1. Now let's simplify this. I have 1 over. Now what's 1 times anything? Well, 1 times anything is just itself. So I have 1 over 9 to the 1/2. Okay? Now let's continue on. Now I have 1 over, now 9 to the 1/2. Think about your model. Put the root, the big number, goes right here. The top of your fraction goes right here. The bottom of your fractional exponent goes right here. So I have 1 over the square root of 9. The square root of 9 is 3. So my answer is 1/3. This equals this. Look at that. Okay? Not too bad. Get rid of your negative exponent first, and then take your fractional exponent or your rational exponent, whatever you want to call it, and simplify it down to a radical, and then solve the radical. Not too bad, guys. Okay, let's take a look at the next problem. 8 to the 2/3, okay? Now, I do not have a negative exponent, so I'm good to go ahead and take this and change it over to a radical. Your big number base goes right here. The top of your fractional exponent goes here. The bottom of your fractional exponent goes here. Now, you can solve this 2 different ways, okay? You can take the cube root, forget this 2 for a second. The cube root of 8 is 2. 2 times 2 times 2 is 8. So the cube root of 8 is 2. So put a 2 here, and then bring down your power and put it here. And then 2 times 2 is 4. That's one way to do it. Or you can do the power first. 8 times 8 is 64. So now you have the cube root of 64. And the cube root of 64 is 4 because 4 times 4 times 4 is 64. Either way works, okay? And then lastly, one more. 32 to the negative 3/5. Now once again, we have a negative exponent. So let's get rid of that first, okay? Remember, I can put this whole thing over what? 1. And then I can bring this down to the bottom, the base and its exponent. So now the 3/5 becomes positive. There's nothing left up top, so I'm going to put a 1. Alright? Now, let's simplify this. Anything times 1 is just itself, so I have 1 over 32 to the 3/5. Alright? So now I can take my denominator, 32 to the 3/5, and write that as a radical. So 1 over, put your radical, here's your base, 32. The top of your fractional exponent always goes here. The bottom of your fractional exponent always goes here. So now I have 1 over the 5th root of 32 cubed. Now it's up to you. You can take 32 times 32 times 32 first, and then whatever you get, take the 5th root of it. Or you can take the 5th root of 32 first, and then whatever you get, take it to the third power. That's what I'm going to do. So the 5th root of 32 is 2. Think about it. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the 5th root of 32 is 2. And then bring down your power of 3. And 2 times 2 times 2 is 8. So there's your answer. 1/8, just like that. Okay? So I'm not saying this is easy. It's going to take some practice. But really, it's not that difficult. Just take your time. Use the steps I've given you. And you should be okay. Alright? Alright, let's continue on. To finish things up, it is really important that you know how to use your grapher when it comes to roots and exponents, okay? So, now some of you don't have a grapher, so you have to look for different buttons. Listen, contact me, email me, let me help you if you cannot figure out how to do this with your calculator, because I will teach you. If you'll take a picture of your calculator, call me, email me something, and I will help you figure this out, okay? Let's look at some problems that cannot be solved without a calculator, okay? Here we go. Alright, now, if you have a grapher, now I know some of y'all have newer, updated TIs, but still the steps should be, for the most part, pretty much the same, okay? So let's start off with the 5th root of 108. How do you type that into your calculator? Well, first of all, you need to push the math button right here. So make sure your screen is clear. Turn your calculator on, of course. Then push the math button right here. After you push the math button, option 5, okay? Now, actually, I did make a mistake, and I apologize. I should have put a 5 first, so let's clear your screen. Let's start all over, okay? First of all, you type in your index, okay? So type in your index at 5, then hit math, okay? And then after you do that, scroll down to option 5. Option 5 should look like this. It should be an X with a radical. Well, because you put a 5 here, now if you scroll down to option 5 and hit enter, this should pop up on your screen. That right there. And what you told the computer is that you have a 5. This 5 right here is an X right here. Okay? So you type your 5 first. You type your 5 first, and then you go to math, option 5, and this pops up. Then type 108. Okay? So the fifth root of 108 is 2.5508. So hit enter, and this will pop up 2.5508. Okay? Play around with this, make sure you know how to do that, okay? Now, let's go on to a more difficult one, because now I've got a 2 out here and a 7 right here. So what do? Well, a 2 next to the radical means times, okay? So, first of all, you want to hit 2. Go ahead and type 2 into your calculator. Then hit times. And when you hit times, this will pop up right here, okay? Then you want to type in a 7. So go ahead and hit 7. And this will pop up, okay? And then hit math, option 5. And when you do this, it'll pop up right here, of course. So what you've told the computer is you have 2 times the 7th root of 210. 2 times the 7th root of 210. Hit enter. And you will get 4.2931. Of course, I'm rounding these off. 4.2931. Okay? And guys, let me say one thing. I'm really experienced with these calculators, but as I was typing this in up here, I was having my doubts, okay? And for some reason, this is not working. You should not get this right here. That is not accurate, okay? Let me play around with this just for 1 second here. Yeah, that is not accurate, and I apologize. No, that's accurate. That's exactly right. So that's good. Okay. So everything is good on that. This is exactly how you want to type it in. So we're good. Okay. Now let's try the last one here. Okay. The cube root of 720. Now there's 2 ways to do this. Before we type anything in, would you please push your math button? When you push your math button, look at option number 4. Option number 4 is a cubed root. So if you want to, I just taught you to type your index in first with the root, okay? And that's a great way to do it. In fact, you can type in a 3 first. That's your index, okay? Then hit math, then hit option 5, and this will pop up. And then hit 720. That's no problem. Please feel free to do that. You'll get the right answer. But another way to do it is this. Since option number 4, when you push math, option number 4 is a cubed root. Instead of typing in 3, just hit math, option 4, and this will pop up on your screen. And then type in 720. Either one of those 2 ways will work, okay? It really doesn't matter. You will get 8.9628099493, okay? So if you want to, type in 3 first, then hit math, then option 5, and this will pop up. And then 720, or you can just go to math first, hit option 4, and this will pop up cubed root, and then type 720, okay? Any of those ways are fine. Now, let's take a look. Now let's move on and take a look at solving some fractional exponents with a calculator, okay? So here we go. Remember, this button right here is your exponential button. So we should be okay as long as we're careful with what we type in, okay? Now, let's start with this problem right here. On your calculators, you would type in 2,401. Go ahead and type that in, okay? Then hit your arrow button, and this will pop up. And then you must use parentheses. So, if your calculator does not put parentheses for you, So type in the base first, then your exponential button, and then 1/4 in parentheses. Let's save this one for last, okay? Let's jump onto this one here. Alright, let's go ahead and solve this one. So first you type in 6, then hit your exponential button, then parentheses, then 3 divided by 4, and then close your parentheses. Alright, let me do that quickly with my calculator. You will get 3.8337 rounded. Well, that's 3.833658625, okay? But I rounded the 6 up to a 7 here. But there's your answer. Now, I saved this problem for last here. It's real important you understand that this problem here is totally different than this problem here. They should be entered two different ways, okay? Do you understand? If there's no parentheses, then push your negative button right here, not your minus button, okay? Your negative button. Then 512, then arrow, and then 1 divided by 3. Let me do that real quick. And you're going to get -8. Now, I want you to type in this problem with parentheses. Now, in this case, you're going to happen to get the same answer, but that's a coincidence. That won't always happen. So if there's not parentheses around the base, don't put them in over here. If there is, then put them in. So if you were typing this into your calculator here, you put your parentheses first, then -512, then close your parentheses, then arrow, then parentheses, 1 divided by 3, then close your parentheses. Alright, and if you'll do that, like I said, you will get the same answer. That's not always going to happen. So make sure you put parentheses when they're there, and don't put them when they're not there. Okay? And that's it, guys. I mean, just a real quick 30-second review, okay? I gave you a lot of information today about what a radicand is, what a radical is, and what an index is. We talked about even indexes having technically more than one answer. Odd indexes have one answer. We talked about even roots cannot have a negative radicand. Odd roots can. We talked about solving different roots. We talked about solving fractional exponents, and we talked about solving these by some of these here by using a calculator. We also talked about simplifying fractional exponents, okay? So that's it, guys. I hope this video has been a help. If you have any questions, don't hesitate.